Hello, everyone. Welcome back to another episode of the Scorpion Movement Podcast. I'm your host, Jordan. And today, for what marks the 8th episode of this podcast, I'm joined by my co-hosts and good friends, Jacob and John David. Now, for some background, the last time John David was with us for a podcast was in April or so, when we discussed topics and unfolding developments such as the brain-computer interface, DARPA, the deep state, more controversially, the virtualization of reality. Topics which is as wide-ranging and diverse as they may seem actually closely intersect and interlock, not only with each other, but with the topics that we're going to discuss for today's podcast, which are likely some of the most dense and difficult of any that we've covered over the course of our entire year or so as a creative collective. We're going to be wading into some pretty heavy and deep intellectual terrain today, which of course just makes it all the more exciting to be here and to be joined by my friends Jacob and John David. And to be frank, we may even have to record a part 2 for this podcast, considering that I don't expect us to run for much longer than about an hour to 90 minutes or so, which isn't quite sufficient for the complexity of the topics and themes we're covering today. And with all that being said, before I jump into the introduction to the topics, which is necessary to provide here, considering their complexity, those topics being quantum mechanics and consciousness, Jacob and John David, is there anything that you guys would like to say or chime in with? Anything you'd like to get out of the way before I proceed with the definitions and the podcast?
Yeah, hey, so what's good? I wrote the general theory of quantum consciousness. It really gets in depth to what I call true reality versus objective reality, retrocausality, attraction, the idea that consciousness is inherently quantum in nature, and what is this true reality and what are the hints to it if there is a true reality, which everything points towards.
Perfect.
I'm the author of that paper. I wrote that paper.
Yeah, it's a
It's
great
all from
paper.
me right there.
Yeah. Jacob, anything that you wanted to contribute here before I jump to the definitions?
Only thing I wanted to contribute was don't turn on your camera because it messes up my OBS.
Okay. John David got that warning.
I got you.
With that being said, what prompted today's podcast was a series of discussions that I've been having with John David over the past couple of weeks, past couple of months, concerning the intersection of these two topics. Now, they're fairly broad, so there are many areas that we can branch off from here, and those topics are quantum mechanics and consciousness, which is what we'll be discussing today, and specifically the intersection of those topics. So, whether or not quantum mechanics could actually provide an explanation for consciousness, which is one of the key missing puzzle pieces, I'd say, of science and of our current scientific understanding of reality. Now, as I said, there are countless areas and themes to which we can branch off from here. Quantum suicide and mortality, cosmology, mysticism, God, numbers. We're going to talk about all of these and more. But I want to begin by clarifying some basic terms and concepts here. So, first, we have quantum mechanics, which I'd say can be broadly defined as a very fundamental theory of reality, a theory concerning the nature and operations of reality at the subatomic level, which would definitely be a key point of differentiation between quantum mechanics and earlier theories of the fundamental nature of the physical universe, such as Newtonian mechanics, classical mechanics, which quantum mechanics usurped in the 20th century or so. And in a reflection of this nature, of this foundational aspect, quantum mechanics really constitutes the bedrock and foundations of countless academic disciplines today, countless scientific and technological fields, from quantum chemistry to quantum computing, which I want to talk about because there are some interesting concepts in that field. And in a sense, I think that quantum computing is actually the future of technology, to be honest, to quantum field theory and even emerging fields which are quite recent but which hold a lot of potential, such as quantum biology, for instance. But ultimately, what I think is much more important in this exercise of disciplinary gatekeeping and identification and nitpicking between different academic fields is recognizing, and I'm sure John David will agree with me, that any investigation of reality, which is really the most important investigation that can be even undertaken, because if you want to know anything about any given topic, well, reality is the bedrock of that topic. It's what even affords the possibility of the exploration of that topic. We just think about it on a fundamental level. Learning about any topic, what that really means is that some form of conceptualization or abstraction is being engaged in. So there's a cognitive component to this. To it, there's this, at least granted that it's being performed by a human, essentially. And what cognition actually is and what intelligence is something that we're going to dive into. I think quantum mechanics can provide an interesting explanation from the more murky areas of those two concepts. But as I said, any investigation into reality really is just concepts and abstractions that are issuing from some type of agent, right? So we'd think of it generally as the human, but it can be any form of intelligence. So it can even be an AI or something. And simply put, that constitutes a part of reality. Because what is the human? Like, from a scientific perspective, the human is ultimately, matter, neurons, neurotransmitters that are firing. And obviously that presupposes, you could say, a materialist picture of reality, which I do have some problems with. And that's something that we're definitely going to delve into when we talk about materialism and physicalism, how they're for the most part the dominant modes of understanding the world today, at least from the scientific community, despite the fact that I would argue they're actually self-contradictory at a fundamental level, and quantum mechanics can help show that. That's something John David and I are going to talk about in depth. But if you, even if you assume that that's incorrect, fundamentally you would have to engage in a form of reductionism and understand that, okay, well, even if physicalism is wrong and the human being can't just be reduced to, mere matter or particles that are floating in this, this within this geometric prism, basically, it has to reduce to something. And so now we have some thinkers, and this is what John David and I are going to talk about. There's some thinkers who actually think that, in a sense, in a certain broad sense, consciousness itself and the human mind and really the human fundamentally reduces to what's known as a walking quantum wave function. And that's where it gets very interesting. And so when you consider that, any exploration of reality has to take into account the findings of quantum mechanics. So this isn't something that you can just limit to any specific academic domain. You have to have an interdisciplinary mindset here. And you have to realize that even philosophers, for instance, who, they don't go about exploring the world in the same way as scientists because they use conceptualizations or rather than these mathematical calculations. For the most part, obviously there's some exceptions in analytic philosophy and mathematics and things like that. But even they have to take this into account, and that really just illustrates how fundamental this is. So that's what I'd say about the nature of quantum mechanics. Now, consciousness, John David, do you want me to briefly explain how this relates to consciousness and physicalism, or do you have something that you wanted to insert here? I know you wanted to talk about some basic concepts like the virtual causality and the wave function collapse and those types of concepts. So do you want to chime in here for a moment?
Well, yeah, to add on to what you said, I definitely agree that this is very important for every field, every domain, as it is the quantum world which underpins physical reality. And that's what has to be observed and known as a fact here.
Yep.
But now to give the audience some background. Okay, so the wave function collapse is essentially this idea. There's a sign for it in quantum mechanics when you do equations. But it's essentially that a quantum state can either be, let's say the quantum state was represented by a cat. The cat can either be laying up, sitting down, or not existing at all at the same time. This completely defies our understanding of physical reality where things are set. Like you either have the number 1, 2, 3, or 4. In the quantum world, something can be 0, 1, 2, or 3, or all of them at the same time. So it goes against what we know as physical reality, which a lot of scientists over time have debated over this, such as Eugene Wigner. He would actually talk about this with Einstein. He was fascinated by this, and he noticed that there was this relationship between the observer and the collapse of the wave function, because the moment an observer observes the wave function, it collapses into one state, and they don't know why. Even till today, in 2024, we actually don't know what makes something more probable than the other. Or we just know that when an observer observes, it collapses into one state, but we don't actually know why. I get into the paper into some possible reasons that I think may constitute a more probable wave function collapse, but still, I think it is very deep and complex and beyond something that you could limit to one explanation. One of those explanations I said, though, is that the idea of retrocausality. I think Wigner did some experiments on this, and this has now been proven. You can go Google this. But essentially that a future it was something like a future result or something with a future resonance or is something affected the experiment being done in the past. I'm trying to think how to word that exactly. Does that make sense? That makes sense.
You could say it calls into question the conventional understanding of time, of time and space, and I think
right. But yeah, that's conceptualizing it. But I'm trying to explain like the experiment, how it worked.
Yeah, well, time.
You guys can go Google it.
Yeah, time and space are definitely two concepts that are going to keep coming up again and again here. I mean, they're very foundational, very significant. Obviously, I think one theme that's very significant that I want to get out of the way here, and this ties into something I've been exploring in great detail recently, is this concept of reification. I think that's going to be very significant here. Because, how that works is, so, reification, and I'll explain why this is significant for quantum mechanics. And by the way, there's so many things that just came to mind while listening to you talk just now, John David. I mean, this is such a rich topic, and there's so many different directions that we can go in. But
yeah,
to explain what this is, so reification, what reification is essentially a category in the study of logic, so in mathematical logic and formal logic, which is something I'm quite interested in, especially recently, because logic is the bedrock of argumentation, and I think there's something to be said about it, perhaps whether or not it actually is an aspect of reality, fundamentally of physical reality, or if it just lies in this conceptual realm, or whether or not you can even differentiate between actually the realm of concepts and ideas and abstractions from physical reality.
Plato talked about that invisible thought forms and shapes.
Platonism is going to be very important here. That's going to be a key distinction, because I think, to be honest, I think quantum mechanics actually points towards a lack of any real demarcation or differentiation between the two men. I think that's the crazy aspect of it, and it's what it is, and this came up when you were talking about the observer effect. What it is it's almost reaffirming the role of the subject and the importance of the subject prior to reality, in a sense. So it contradicts this mission of technocratic modernity, these systems of control that rule over us today, that you see with in these manifestations that have now entered the cultural consciousness, like the World Economic Forum and Klaus Schwab and all of these overlords that we've talked about time and time again on this podcast. And I think that too, and this is crazy because it's so interesting how quantum mechanics actually has real social and political significance. I know that sounds like somewhat mystical, but this is very mystical in a sense, so it has to be said. But it actually negates.
It's the invisible world, bro. It's the invisible world that dictates the physical world.
What's crazy is when you dive deeply enough into it, and I'm going to explain this later in more detail, like my original thoughts on this, it actually negates the rule of these overlords, of these these technocrats and bureaucrats like Klaus Schwab, who have these insane depopulation plans, and they basically want to phase out humanity and replace us with these transhuman cyborgs, just insane shit that we've exposed time and time again on this podcast. But when it comes to reification, right, what that is fundamentally is a category error, concept in logic, where you analyze a certain concept or thing as if it belongs essentially to a different category than it actually does, which causes a lot of problems. That's a simple way of explaining it, right? But it's a category error where you confuse or conflate an abstraction or some conceptualization, essentially an idea, for physical reality, and that causes many problems. Now, I've been interested in this recently, first because I was thinking about economics and capital, the economy. Georgi Lukács, he's an interesting thinker in this regard. I think he explained it quite well in some of his works, even though it's not unique to him. When it comes to the study of the economy and of capital, people like Marx and Debord have talked about this, Debord of the French Situationists. I think even some contemporary thinkers like Zizek have talked about this. But to be honest, I don't really like reducing any ideas just to certain figures who have propagated them in one form or another throughout history. I think that's kind of a pointless exercise. You can't just analyze the ideas in their own right, just on their own merits. And that's what I'm going to do here today. But when you apply it to the study of the economy, what I was thinking about is how, and it's quite controversial, but I think that I have a big problem with, and you'll see how this ties into what we're talking about with quantum mechanics and everything, because it might seem unrelated at first, but everything is interconnected, right? Theories of everything, we're going to get into that. But I was interested in this because I think that neoclassical economics, for instance, which is the dominant form of economics in Western academia at the very least, in the East, in countries like China and Russia, it's a different story, as is the case with all social sciences, right? Because of how subjective they are. But neoclassical economics is intellectually bankrupt, I'd say, because of this problem of reification. It's assuming that the economy is this static entity. It's something that just exists as part of the natural world, almost separately from humans in a sense. And it's proceeding on the basis of that assumption, economists, the priests of capitalism in a sense, I think certain thinkers said that back in the day, begin to analyze the so-called, the assumed laws of the economy, the laws and mechanisms and the causal factors.
I've thought about this, yeah.
Of the economy, things like the laws of supply and demand. But what they're doing here is, and I've written about this in more detail elsewhere, so maybe we could talk about this on a different podcast. Just one that's more
almost like invisible principles that kind of guide this, right?
But the problem with that is what they're doing is that they're not realizing that these functions, which, by the way, are not even apparent in all economies, and it's for a certain reason, the same reason why this is a fallacy of reification. These functions and these mechanisms that they think are inherent to the economy only exist insofar as they are assumed to exist by humans, by societies, right? Because all economies are fundamentally embedded in societies and cultures, and those societies and cultures shape the function of the economies, not the other way around. That's something that neoclassical economics fundamentally ignores. It can't account for that. And why? Because these supposed laws, mechanisms, these supposed functions of the economy are just abstractions in a sense. They're almost like these platonic ideals that are just assumed to exist, but again, they only exist insofar as they're believed to exist. So ironically, in actually assuming that the economy functions in this fixed manner, according to certain causal laws, they're actually willing that into existence. That's the crazy part of it, in a sense, and that gets into some deep metaphysical territories. That gets actually
that's very deep.
Yeah, that gets into quantum physics in a sense regarding what the nature of reality is and how it relates to subjectivity. Because you talked about I believe you touched on the observer effect briefly, John David. But another aspect of the observer effect that's so interesting to me is that for certain physical systems, so for a closed quantum system, the entities within it don't actually even come into existence until they're observed. Think about that. And now think about what some of the people that we've talked about before, like Nick Land and Mark Fisher and everyone who's affiliated with the CCRU talked about, which is this concept of hyperstition, basically of fictions that make themselves real in a sense. This is almost the current state of reality, of late modernity. We're dominated by these spectral abstractions and these ghosts, these ideals that we assume to exist, to have some existence in the natural world, but that they only even appear as such, as having this existence insofar as we think that they do, right? It's almost this line that's passing through from the abstraction to reality. And so and when you don't realize that, or when you enshrine that, you're almost, you're enslaving yourself in a sense. Civilization enslaves itself as a result of this process. That's the true nature of neoclassical economics. It's a control mechanism in this sense, right? If humans stopped believing in this, if they stopped believing that the economy should function in a certain manner, for instance, in this kind of capitalistic style, which is what neoclassical economics defaults to by nature of this fact of reification, it wouldn't function as that. So it's fundamentally bankrupt on intellectual level. Like, do you see how it's not actually scientific in that sense? And that explains why, for instance, it can never account for social and cultural differences that might actually affect economies. So how economies function in different societies. Because what it's doing is it's reifying an abstraction, and that abstraction basically just floats essentially in this ideal platonic realm. So it's completely detached from actual reality, from physical reality. We're in this reality. No, we do see differences, between societies in regards to how the economy functions. That can't be accounted for because it's an abstraction. But because of that fact, on that note, that's why it's so powerful. That's why it dominates us. And that's why it enslaves us, and that's why we can't move beyond these systems of, debt, slavery, and wage labor and things like that. It's because we're reifying these abstractions. So that's kind of a convoluted argument. How does this relate to quantum mechanics? How does this relate to consciousness? How does this relate to the issues that we're talking about today, which seem to be a bit more scientific, right? Even though on that note, by the way, what's interesting is that John David, are you familiar with some of the fundamental models that are used nowadays in game theory and rational choice theory, which are kind of the basis of neoclassical economics? Because this gets into some interesting stuff regarding quantum wave functions, like the prisoner's dilemma and things like that.
I've heard about these and I've looked a little bit into them, but I'm not too familiar with them.
Well, how this is significant is, these models are really the basis of not just neoclassical economics, but sadly many paradigms nowadays in the social sciences, which I think are so destructive, like rational choice theory and game theory, which
like with groups and
which aim to model the interactions of rational actors. That's the simplest way to explain this. And some of the models that they use to justify this and that are part of this are, for example, the prisoner's dilemma. You have different prisoners and they're all trying to get the best deal possible to ideally to escape from prison. And so they essentially bargain with each other and they connect these, they conduct certain deals and wagers and things like that, these bets, right, so that they can get a better deal, get a better chance of getting out of prison. It's funny that it's a prison because the giant system that this sets up and that this constitutes actually is a prison in a sense, in a metaphorical sense, in that it literally imprisons humanity and it imprisons intellectual activity in a sense because of how limiting it is, how it traps you in this cage, this jail cell, right, and intellectually. But what these models assume fundamentally is that, well, like I said, you have rational actors. So that's actually applied to the human realm, to the social world. And so it's assumed that humans basically are utility maximizers. People like Adam Smith talked about this in the past, right? That they will seek to maximize benefits and minimize costs. Now, there's this fundamental notion in neoclassical economics of utils. How many utils are acquired from certain economic decisions? And they define utils as units of satisfaction, right? What happens when you subtract the costs from benefits? So it's all very mathematical, right? Well, the empirical, and this is so devastating, the empirical legitimacy of this, as demonstrated through actual studies and statistical studies and statistical analyses that are performed on this, is extremely low. It's terrible. I mean, it's laughable. And this alone should be enough to point out the intellectual bankruptcy of these types of models, which are so ubiquitous nowadays in universities, and that's for a reason. They're control mechanisms. It's sad how you go to any American university and they teach this stuff in the social science departments. I've even encountered this firsthand. But what I mean by the empirical legitimacy of this is extremely limited and low, is that we have countless studies showing that humans actually don't act in this manner. So what they do in these studies is they put people in these scenarios, these prisoner's dilemma scenarios, where they have to break out of some difficult scenario, right? And they don't actually function in this rationalistic manner, this hyper-rationalistic, utility maximizing model. They completely negate that. They act in ways that are contrary to that, actually. And there was even a good quote from this one thinker. I forgot what his name was, but he said something along the lines of, the only people who actually act rationally in the manner that neoclassical economists presuppose as the basis of their mathematical abstractions of human society, that ain't a model human society, you could say, to be more specific, are two types of people: psychopaths and neoclassical economists themselves. But where this gets crazy with quantum mechanics is that those models, right, these simulations in a sense, I think they actually, what they presuppose? They presuppose this physicalist picture of reality, so that existence fundamentally reduces to the physical world, and from there you get materialism to matter, because matter is seen as the constituent element in a broad sense. And I'm not using that in the sense of chemistry, chemical elements, but in a more generic sense of the constituent element in the foundation of reality, of physical reality. And from there they presuppose that, well, there's actually a certain determinism to reality, right? Because if it does reduce to the physical level, and if it does reduce to quantities, right? So for instance, you can map out the trajectory that a ball will take based on the understanding of gravity and of these physical forces. That's, you think of the mathematical models that are used to describe physical reality. That actually assumes a certain mechanism to reality, right? Think of Newtonian mechanics, what's usurped by quantum mechanics. That assumes a fundamental determinism to reality. And once you assume that, and once you recognize that, well, within this worldview, this very myopic worldview, humans are nothing more than just pieces of matter, just collections of atoms, giant collections of atoms, right? Which, by the way, the implications of that for free will and just for life itself, and John David, we should talk about free will versus determinism, is super significant. I mean, that's horrifying. It's like, I don't understand how the people who assert something like that, because there are many actually, including many top scientists, can even go home to say that they love their wives and their children, because, well, how could they say that they love their wives and children when they come home after a busy day of work, when it's just predetermined chemical reactions and the products of neurotransmitters firing? There's no actual meaning behind it, right? It just happens in a sense. That's what.
Well, I think there's more than neurotransmitters going on there.
Yeah, there's more than that, but that's what it reduces to when you presuppose physicalism.
No,
right?
I think. Oh, okay, yeah.
But then, but I think quantum mechanics actually negates that. It moves us towards a more indeterminist picture of reality. But the thing is, once you presuppose that type of determinism, then you actually do have a rational basis for assuming that humans will act in such a manner that it can actually be modeled in a rational manner, right? That you can say, okay, if this happens, so if X, then Y, like the modus ponens in logic, right? The logical contraposition. That can actually be applied to human behavior, and you can literally reduce the entirety of society and culture, which seems to be so complex, to just that basic logical principle if you presuppose physicalism. That's why these economists think actually that people will interact in this manner. But the studies show, there's some interesting data on this, that when you modeled humans as walking quantum wave functions, and there's this guy who talks about this named Alexander Wendt. He's a really interesting political scientist, and I think he wrote a book called something Quantum Mind and Social Science, Uniting Physical and Social Ontology. This was a book that he published in 2015. He says that the models that I've talked about, like rational choice theory, game theory, realism and international relations theory would be another example of this. I think it's completely intellectually bankrupt. And it's sad to see people like John Mearsheimer, who are otherwise so intelligent and knowledgeable, push that. But all of those models, they presuppose this Newtonian picture of reality that I talked about, this deterministic view. But when you assume that humans are walking quantum wave functions, they actually behave in ways that contradict these models, these mathematical mechanistic models. And dude, John David, you know where that gets us into? That gets us into free will versus determinism, what causality is, whether or not causality exists, or whether or not it's something that we essentially just perceive, right? Which is what Kant was getting at in his transcendental idealism, right? Where he says that it's just that belongs to the phenomenal world. It's just an imposition upon reality. So Kant's coming back. I don't really describe myself as a neo-Kantian, but I think it does have some legitimacy, and I do think you do have to revive Kantian thought, to be honest, to deal with the big questions in quantum mechanics and the big questions in contemporary science. But that also gets into the question of things like Gödel, right? We were just talking about Kurt Gödel before we started the podcast. Gödel's incompleteness theorems, demonstrating the limits of logic, in a sense, and of logical systems. So there's so many directions that we can go in from here. And it all starts just from this idea of reification. Now, I've been talking for a really long time. I had some more notes about reification, because I talked about it in the economic realm, but then I showed how that it's not just presupposing statements about the economy, but in doing that, it's presupposing certain ideas about the nature of reality, of the universe, of the physical universe, of physicalism, right? Assumptions about determinism, things like that. And now that's going to get into, I'm writing this down actually in a notebook right now, this difference, or this assumed difference between abstractions and physical reality. This is something that I want to talk about because I actually, and this sounds really crazy, I don't really accept the existence of a physical reality. I think it's actually a self-contradictory concept at a fundamental level, and I think findings in quantum mechanics can actually affirm my viewpoint. And I think once you move beyond the picture of a physical reality, you really open your mind, and you open the doors to not only mysticism, in a sense, mysticism, a possibility of the supernatural, like some type of explanation for supernatural events that we otherwise had no way of explaining or fitting in within the parameters of modern science. And then from there, you actually cross over into theology, and possibly even God. And that's where it gets much more controversial, obviously, because it's religion, right? I've been talking for a long time. I will dive more into reification as applies to different areas. But John David, because I've been rambling for so long, is there anything you wanted to say, or did any ideas pop into your head based on what I talked about? I know it was kind of a mouthful, but I just want to give you a chance to talk right now.
I definitely thought of a lot of ideas from what you said.
Yeah, I know it was
I will. Yeah, no, that was very good. Very insightful for the audience as well.
Yeah, thank you.
Very thought-provoking.
Yeah.
I will say, when you're approaching the unclassical world, you cannot go within the same laws and ways that you think of the already classical physical world.
Yeah.
Because then fundamentally you're lying to yourself. You know, for example, I think that it's so complex and bending because, for example, I think if there was a guy and he was thinking of a super futuristic sci-fi fantasy design suit that like he was drawing up in his notebook and it was inspired by fantasy thinking. Let's say now in the future, he was to make that fantasy suit in real life. And it was inspired by the fact that in the past, he had that inspiration. Now in the future, that real suit with the technology over time that was put to make the suit real, that is now a part of actual reality inspired by the past with imagination. And in your classical thinking, you might be like looking at it in a linear way. Oh yeah, okay, you had a imagination and then over time it led to the creation of this. But in reality, it's actually funny, in true reality, it's so bending, it goes against linear. It might actually be that the future was already affecting the past because for the thing to exist now, it had to already have been inspired by the past, which is fantasy, whatever you define it as. True reality might not actually care. It was just the catalyst for something in the future to be possible. And the fact that you were making it in the past, like thinking of the idea, that might have been caused by the future where it was created. So the future creation of it was already affecting the inspiration to just draw this up. Do you see what I'm saying? But
exactly,
it might actually be so complex that they're actually connected and intertwined. But through your perception, rationalization, and classical thinking, you're like, oh no, it's just in a linear way. He thought of an idea and it led to some creation later. No, the reality could actually be much more complex, but you have to let go of these notions that you have.
Yeah.
That's also why I think that like a lot of people are not open to quantum or they kind of push back on it because there's an aspect that you have to let go and open towards.
Yes.
You know, it dude, I'm telling you, it's the real reality and it underpins physical reality. I said earlier before we actually started the pod, I said that the quantum reality dictates physical reality. I don't know necessarily if it's that's actually kind of simple, even though it sounds complex. I don't think that it dictates physical reality. I think that it underpins it. There might be so many things that are actually dictating what goes on. The whole universe might just be this constantly ever-changing, fluid-flowing energy where that now you can bring in other concepts like vibrations, fields, energy, this, that, etc. And that those things can actually help answer the quantum wave function collapse because now you have other factors that can influence a likely wave function collapse. Is the bird gonna lie down, sit up, or fly? Okay, you observe it in one collapses for whatever known reason. Okay, but why? And now when you bring in these other factors, it might help actually answer what caused one collapse to be likely over the other. And it can be so complex, Jordan. This gets into what you were saying about things being connected. Dude, it can be... I thought about this before writing the paper. I didn't put this in the paper, but I almost see it like a... have you ever seen a traffic light system?
Yes, yeah, obviously.
So when you're driving on the road, you see the light go from red to green. And for you, it went from red to green. But in reality, the whole traffic light system, it's so big and so complex, and they're actually all working together at the same time and everything. But for you, it went from red to green. I actually think that even with vibrations, energy, all these things, the wave function collapse of one collapse being likelier than others, it could be influenced by so many things in nonlinear time, future to past to present, other energies, the connectedness of all things. I'm telling you, dude, it gets so complex. But this is the thing. Were humans made to understand this, right? Were they? We're humans. We have five senses.
Yes, exactly. No, that's actually really that gets into the theological aspects of this, actually.
Right.
Arguments for the existence of God. It's funny that we talked about Kurt Gödel, and he actually came up with, he was quite a strong believer in the existence of God, and he came up with, for instance, the ontological proof. But on this note, obviously I'm going to get back to the concept of reification, but it's all related, right? On that note, man, you really got me thinking, because when you're talking about these aspects of nature, of the universe that seem to defy human understanding, well, what I'd say here is that, well, obviously I mentioned how quantum mechanics negates it negates an indeterministic picture of reality, and it actually asserts something more close to probability being to probability being a more fundamental principle of reality, something that underpins it and governs it in a sense, right? If you could describe it like that. And obviously now determinism is actually much more compatible with the human tendencies, or the tendencies in human thought towards these easy answers, essentially. This accessibility.
Exactly.
It's much easier to map mathematically, right? And there's this tendency in thought, which is a very flawed tendency, that which can be modeled in mathematical, through mathematics, through these complicated equations, these abstractions, these modeled graphs, automatically carries a higher degree of legitimacy because of that fact. And that has so many problems. And we even see that actually manifest on the social level, on the economic level, with the fact that, the social scientists who have always had a greater influence on governments, for instance, and on policymakers, or generally economists. And they've always had the highest salaries, and that's because they carry this air of scientific legitimacy in that they claim to provide these mathematical models that definitively explain how the economy works, right, from microeconomics to macroeconomics, and so they seem more convincing to not just to the public as a result of that, but to these policymakers, people who actually pull the levers of society, right? Whereas those who utilize more qualitative methods, which account for the existence of differences from between societies and cultures, tend to be somewhat marginalized. Just literally within academia and within society, they have lesser paid or are less influential in government. That already demonstrates that, and how all this is really a control mechanism, right? This physicalist picture of reality, this deterministic picture of reality, they're actually control mechanisms that manifest on a social level, and that's why quantum mechanics is so significant in this regard, because it negates that. But when you think about it, the negation of that determinism, and how some of the findings in quantum mechanics actually, they almost point towards a complete reevaluation of logic, of mathematical logic. Think about
this,
because the fundamental principle that underlies mathematics, in a sense, is in actually really, I don't want to say human reason, because I think it's not true, but the understanding of the common understanding of human reason, of human thought and intelligence, and the understanding that has to arise actually as a result of a certain understanding of space-time, right, of reality as space-time, basically, which I think is flawed, of reality as physical, is the identity principle, the principal identity. And it seems basic at first, because you learn this in your first, not in your first, but in any basic math class in school, like elementary or middle school, right, depending on how advanced you are, but the principle that A equals A. So, and that's considered to be fundamental. So if you wanted to prove something, for instance, if you wanted to devise a mathematical proof, let's say that you have an algebraic equation, and you have one side of the equation equals another side, right? It's already contained within the initial formulation of the equation, you could say, because of the equal sign. But if you wanted to prove anything like that, you'd have to reduce it really to the level of A equals A. That's how you would solve any proof like that, right? So there's that fundamental principle, which seems to govern the world in a sense, at least in the classical picture, which we know is now kind of outdated. But many of the findings of quantum mechanics actually negate that. Because think about it, and then this will actually tie into broader issues relating to what logic is, what mathematics is, and whether or not they're actually aspects of reality, inherent aspects, or if they're just constructions of the mind in a sense. It gets very complicated here. But we have principles like quantum entanglement and quantum superposition. These are fundamental. And then you have the very well-known thought experiments like Schrodinger's cat. The cat that is at once dead and alive. And to simplify it, so that we don't have to get into the mathematical equations and all of that, and the formulas, to simplify it, you can describe these principles like quantum superposition as essentially asserting that entities within physical systems can actually occupy two different states at once. But we would understand those states as contradictory. You see what I'm getting at?
That goes against mathematics, because mathematics works in computability. 0, 1, exact finite numbers for computation.
And that's the basis of classical computing, you could say, right? Now, quantum computing is obviously moving beyond that, and so that's why I think it's going to produce some insanely advanced technology in the upcoming years, the forthcoming years, which is why people should be paying a close attention to it. But yeah, like you said, it negates the principle of identity, which goes back to people like to the Greeks in a sense, like Aristotle. And dude, Aristotle is actually so significant in this because in his in the Physics by Aristotle, very foundational text in Western thought, he tries to come up with a definition of time, but what he actually does is he defines it in terms of space. So in terms of the quantity of time, and so he maps on quantity to space basically, because you can't really conceive of space or of physical space without the concept of quantity, right? Because any physical space it constitutes itself as physical insofar as it occupies a certain quantity of space. So already we see numbers insert themselves here, and now this gets very complicated because that ties into the conception of reality as just physical.
Jordan, you know what's so interesting that I just thought about that you said that?
I have some more that I want to say on this point, but yeah, go ahead, man. Go ahead.
I think it's so interesting that even when it comes to trying to understand a non-classical system, and we can conceptualize, like the fact that we're talking this, and even though this is like beyond physical reality, we're talking about it because we can conceptualize and conceive of it, right? I'm just thinking, imagine something beyond what we can conceptualize or see proof of. Like if we said there's retrocausality, okay, the reason we can say that is a thing that we talk of and conceptualize and perceive is because either we see a proof of it tied to the conceptualization.
Yeah.
Like let's say a future thing affecting the present variables, like a future result affecting present variables in a given science experiment that would prove retrocausality, or the fact that we can conceive of it as a thought form, which Plato gets into, like the world of invisible thought forms.
Yes, definitely.
I just think that it's so interesting that even though this goes beyond our classical notions, the reason that we're able to talk about this or even understand something, you know what I'm saying, to imagine within our visualization of something non-classical, is because we can still visualize it as an aspect of reality. But imagine there has to be things that are beyond unclassical or classical that just are software, like our biology, what like our visualization can encapsulate or just perceive. You get what I'm saying?
Yeah, that's the crazy part, man. Yeah. No, I understand what you're talking about here, and how that relates to what I was just talking about was the so Aristotelianism. The Aristotelian perception of or conception of time and space. So how he defines time as a succession of points, which already places it within this mathematical abstraction, this mathematical conceptualization. It ties it to the concept of physical space, which I think is very important. So that gets into the relationship between physical space and mathematics, which is quite important. And with that being in mind, it's quite interesting that he also was one of the first people to formulate this idea of the identity principle as this underpinning principle of reality itself, which I think is flawed. And obviously quantum mechanics shows how it's flawed with these ideas that we talked about, like the like quantum entanglement, quantum superposition, and some of the interesting thought experiments that have appeared. But what that shows too is, there's this there's this defiance, this negation of logic in a sense, or at least logic as we understand it, because that fundamental principle is thrown out the window of A equals A. That in itself is so radical that it's almost hard to conceptualize. That's where I think you're completely right about all of this being very puzzling to the human mind. And where that's significant, and you get into some really insane mystical territory, is it definitely appears as if there are these aspects of reality, and obviously it's different it's hard to actually differentiate between the makeup and the aspects of reality from reality itself, right? Because of the principle of reductionism. Like, even a physicalist or materialist would assume, for instance, that all of reality is ultimately just composed of matter, or of physical space, of the physical world, right? Mm-hmm. So it can be hard to differentiate between the two. But with that being said, there are these aspects of reality that do actually seem to defy human understanding. It's almost, and I think you were touching on this, it's almost as if they're not even meant for human understanding. And this gets into some very, very deep territory. I wanted to just clarify one concept in this regard, because it's very important, right? So this debate between, I'm actually writing this down on my notebook as we go on.
Awesome.
Yeah, the debate between mathematical Platonists, because we keep touching on this, I think we should expand on it in a little bit more detail just for clarification, for purposes of clarification. But there's this debate between mathematical Platonists versus mathematical nominalists. That's how these two sides are generally termed, right? So, Platonists, and they're sometimes called, I think they're sometimes called realists, and then nominalists might sometimes be called instrumentalists, right? Now those two respectively, realism doesn't necessarily correlate completely to Platonism, or they're not one and the same, and the same is the case for nominalism and instrumentalism, but they generally correlate, right? They generally go along with each other. And this also obviously, this ties into some big debates in the philosophy of science concerning scientific realism versus, what could be termed as, you could say, scientific nominalism or instrumentalism. And the big distinction here would be that scientific realists think that science, in a very broad sense, and scientific models reflect intrinsic and inherent aspects of reality. So objective reality, even though, as I've said, I don't accept the existence of an objectively existing reality. I think that that's a self-contradictory notion, and it's closely tied to physicalism. And now that props up again when you see contemporary debates around consciousness. So obviously we touched on consciousness earlier. That's something we're going to have to tie into more, that we're going to have to explore in more detail, because a key roadblock to reaching any type of consensus on consciousness and what it is, and also a key reason for the divide between neuroscientists and philosophers of mind, both of whom are very intelligent in their own unique ways, of course, very knowledgeable, erudite people, and I have tremendous respect for both. I follow both. I keep in touch with the findings of both. But a key reason for this divide that you see, where I want to save some of this for when we delve more so into consciousness, but a key reason for the divide is that, neuroscientists and most scientists in general, now maybe some people like Penrose, it's not quite clear where he stands on this, but some people like Roger Penrose might not fully agree with the physicalist perception of reality, or conception, sorry. Penrose now seems to be advocating for some type of panpsychism, which is actually pretty interesting. We can touch on panpsychism and what that means, too, because there's actually a long lineage of that within Western thought, going from Plato to Leibniz to Alfred North Whitehead, and even to these various occultists and hermeticists, and all gets very dense and detailed, this historical lineage. But with certain exceptions, people like Penrose, most scientists would be physicalists, right, including neuroscientists. But not all philosophers of mind accept that stance. And I think that divide is a key explanation for why the majority of neuroscientists actually reject the existence of the hard problem of consciousness. Now, what is the hard problem of consciousness? I'll define that soon, because I do want to get back to this point about mathematics, Platonism versus nominalism. But the majority of neuroscientists, and this is actually confirmed, you can literally look this up for anyone who's listening to confirm that I'm right, and I'm not just talking out of my ass. The majority of neuroscientists reject the existence of the hard problem of consciousness. Sorry, my phone's ringing. Let me just silence this here. And anyways, when I say that they reject the existence of the hard problem of consciousness, I'm not saying that, obviously they acknowledge that it can be conceptualized, because when you think about it, anything can be conceptualized, right? I mean, there is such a thing as mathematical infinity, even though it's actually hard to really picture for the human mind. By the way, I do want to talk about infinity later, Cantor and set theory. That's all quite interesting, and how that relates to theology, God, the divine, etc., etc. Those are key concepts here. These neuroscientists would acknowledge that you can conceptualize it, but they don't really bestow upon any legitimacy. They don't think that it's a legitimate problem. They don't think that it's a problem at all, let alone a hard problem, as people refer to it. Whereas the majority of philosophers of mind, based on the recent polls, recent studies, I mean, it fluctuates from year to year, but generally speaking, they disagree with the neuroscientists on that. They do think that it's actually a problem. They agree that the hard problem of consciousness exists in that sense. And not just as a conceptualization, but as an actual legitimate problem, and as a roadblock to the scientific understanding of the mind, right? And of intelligence, cognition, consciousness, right? Because when in the scientific understanding, the neurological, neuroscientific understanding, fundamentally all thinking, all cognition, metacognition by extension, intelligence, human reasoning itself, which is obviously such a big part of what it means to be a human, reduces fundamentally to the mind, right, which is this physical organ, which is composed of matter, particles, right, and so they think that what they basically think is that even if we don't fully understand how something like consciousness arises from the physical and neurochemical processes at play in the mind, in the human brain, what that means is that science just needs to progress further. And that as our technology gets more and more advanced, we'll eventually map it out. We'll find a neurochemical explanation for all this and it'll be solved. So that's what they would say. But then obviously many philosophers of mind would reject that. Right? So yeah, physicalism correlates, it refutes itself, and I'm going to explain why. I actually sent a quote by Roger Penrose, a physicist who's obviously amazing, a very influential figure in contemporary science and contemporary intellectualism in general. Nobel Prize winner of physics in 2020. John David and I have a big interest in him. I included a quote from him that explains quite succinctly why physicalism is self-contradictory, why it refutes itself. I have my own thoughts on that matter. But that generally aligns with scientific realism, right? But contrast that with scientific with nominalism or instrumentalism, very closely correlated. They would say that no, science is just a model and a set of abstractions that human devise as a means of understanding the world, and it never really transcends being an instrument. Hence the term scientific instrumentalism. It's just something that helps us explain what we see that's around us, but that doesn't necessarily mean that it reflects any intrinsic aspects of objective reality. I think you could even tie this into the thought of someone like Immanuel Kant, right? And we are actually seeing. I've heard some people in certain spaces online say that Kantianism is dead, that even neo-Kantianism is dead, that it can't really explain any of the important struggles that are happening at the edge of science right now. I don't think that that's true, and I think the best way of understanding that would actually just be thinking about Kant's transcendental idealism. And to give a big rundown, and John David, you can provide your thoughts on this later. A key element of, if not the linchpin of Kant's transcendental idealism, which is essentially his metaphysics, which it actually encompasses really his entire picture of reality, and he outlines this in Critique of Pure Reason, but also in some other works like Prolegomena and Future Metaphysics. What he says is that time, space, causality, numbers, right? They're just impositions of the mind upon reality. They don't actually exist in themselves. So from there, he differentiates between the phenomenal world and the noumenal world. He says what we see is just a phenomenal world, and we can never really have access to the noumenal world. Sorry, just getting another phone call here. So that would be a very basic rundown of transcendental idealism. I think you could actually, it's not quite the same as scientific instrumentalism. I don't want to confuse people unnecessarily, but you can certainly see a certain correlation. I think it can help people understand what scientific instrumentalism is. Because it can seem quite abstract at first, and the problem is education in America is, to return to the social criticism, because that's a big part of what I do. Education in America is just so flawed and limited that most people, including people who graduate from the most prestigious universities, prestigious STEM-focused universities, we're talking MIT, Princeton, Caltech, etc., may even go through the entirety of even their undergrad without actually understanding these very basic elements of science and of scientific methodology. These really basic debates, which is a tragedy, right? And I wish that they taught this, but hey, we're taking it up upon ourselves to do that in a sense, right? So you can think of how that relates to, and John Dave, I'll give you a chance to talk because, because a rule that I set for myself is to not ramble on for too long, regardless of whether or not I have a lot to say left, whether or not there's a lot that I have to say, because, I just like to give a roughly equal amount of speaking time to everyone in the podcast. But to tie that into this debate about mathematics, so mathematical Platonists versus mathematical nominalists. So the reason it's called mathematical Platonism is obviously a reference to Plato, ancient Greek philosopher, super important. Lots of interesting stuff in his writings. He's such a foundational thinker. Republic's such an important work in political philosophy. He even have his early theories about Atlantis, and there's some people even speculate that the Timaeus, who writes about time, kind of like what Aristotle did in physics, actually provides an early account of this popular conspiracy theory nowadays called the Tartary theory, which is its own rabbit hole. We need to get into that right now. But anyways, with that being said, obviously a really important thinker, foundational in Western thought and in intellectualism. Key doctrine that he has is Platonic idealism. And the reason that I bring this up is you can't really understand this conception of mathematics without understanding Platonic idealism. And now what Plato says is, and some people might have a basic understanding of this because it's filtered its way through pop culture, through things like the allegory of the cave and the Matrix and simulation theory and so on. I mean, that's a very watered down understanding of this. I don't really think that we live in a simulation. I think that's kind of a flawed picture of things. I do think that, as we've talked about, the findings of quantum mechanics definitely show that there is some, maybe not necessarily in order, because quantum mechanics actually aligns quite closely with chaos theory, right, which is something that we touched on in our text messages, and indeterminism, entropy, right? So maybe not necessarily in order, but just, again, these aspects of reality that hint at some sort of transcendent or possibly even divine structure that underpins it, that even possibly even conjures it into existence, something like a god, right? But with that being said is, Plato says, and the reason I bring that up is because I think what many people think of as a simulation theory, or the so-called evidence that we live in simulation, is just a product of them mistaking those aspects of reality that I described, these aspects that hint at some divine or godly underpinning as evidence of a simulation. I think it's a result of a misunderstanding in a sense. But where Platonic idealism comes into play here is that it asserts that what we see, the material world, right, is at best a facsimile and, a hollow imitation, or just a cheap reflection of this ideal world, right? And it's both ideal in the sense that, well, in the colloquial sense, that it embodies this higher realm, higher virtues, like the ideal, superior forms of what we see in the material world, and on that same basis that it transcends the material, it transcends the physical, right? So it sounds quite mystical, but he actually provides some logical explanations for this. He says, for instance, beauty. This is important in his writings on aesthetics. Aesthetics are something that I think about all the time. Art, right? When you think about it, even something like mathematics, it's actually a form of art in a sense. You're dissecting the poetry of reality, right? Same thing with physics. Like, why are modern physicists and cosmologists so obsessed with finding a theory of everything? Well, I don't think it's just because they want to satiate some curiosity about the world, or because they want to have the most objective understanding of the world. It's because there's something aesthetically pleasing and just beautiful about a complete picture of the world that maps out everything, that accounts for everything. There's this, it's this reflection of, this certain spirit, maybe not necessarily Faustian man, because I don't think that's like how Spengler described it. I don't think that's the best way to describe it, but of the limitless potential of human beings. It represents not just this conquest of reality, but this union reality in a sense. We're no longer a stranger, or a helpless pawn, or just a speck of dirt in the face of the vast cosmos. We actually understand it and can commune with it. So there's this very deep aesthetic underpinning, I think, an impulse behind the quest to find a theory of everything. And I think Penrose is getting close to a theory of everything in some of his recent works. But yeah, you can't divorce art from science and mathematics, obviously. And fundamental to art is the notion of aesthetics. And so what Plato talks about here is that we have this concept of beauty, but in the physical world, which is ultimately limited to the confines of our senses, we never actually can see, and it's not even a possibility within this physicalist confine to see or confinement to observe and to apprehend true eternal beauty, because everything that is beautiful in the physical world is ultimately finite, right? And so he points out one of his famous dialogues that, for example, a beautiful person in their youth eventually becomes old. They age and then eventually they die and they shrivel into a corpse, which is, almost the antithesis of beauty in a conventional sense. And so from there, he says that what beauty is in this physical world, in this material world, is, like I said, it's just an imitation or a cheap copy, a facsimile of this more eternal beauty that exists within this ideal realm. So the ideal of beauty, which obviously is something that we should aspire to, we'll never be able to realize it, he says, just because of this materialist confine, obviously there are more spiritual aspects here that he talks about, where he's writing about how, there are ways of accessing the realm of ideals, but it gets a bit mystical from that point onwards, right? So I don't want to go into too much detail on that now, it's not really necessary. But within the ideal realm, you touched on this, John David, the realm of forms, right, of ideals lies the true manifestations of these concepts, right? Beauty, and not just beauty, but many others, right? And so how that ties into his views on mathematics is that he says that, what he says is mathematical entities aren't just constructs of the human mind. They're not just projections that we impose upon the world, this Kantian viewpoint. And they don't just have this instrumental, pragmatic function, this, utilitarian function, where they just seem to conveniently describe the world, and so therefore we use it. No, he says there's this eternality to them. They have this transcendent quality such that they actually exist in themselves independently of any perception, right? And so they would reside within the realm of forms, the realm of ideals. That's what Plato would say about mathematics. Now, I do think actually that, even though obviously we were talking about how quantum mechanics reaffirms and it reasserts this notion of subjectivity, that the subject does not just exist separately from reality, right? He's a part of reality, and he shapes reality in a sense, right? It's not necessarily he, but you know what I mean. And through things like the observer effect and all these other ideas that we talked about, right? This would seem to negate that at first, but it actually doesn't, because what we're finding with quantum mechanics is that when you get down to just think about it, at a fundamental level, what quantum mechanics is studying reality in the universe at the subatomic level. And we actually now can do this and observe it in a sense through the advanced technologies that we've developed over the years, right? We have these particle reactors, everything that CERN's doing, so we can actually confirm this. It's not just something that we think about in the abstract sense. But and this is also why I think physicalism refutes itself, but take, a chair, right? Well, you can reduce the chair to molecules. You can say that it's composed of molecules. Then from there, you can say that, well, molecules are composed of atoms. But with quantum mechanics now, we're aware of the existence of subatomic particles. And we actually can split the atom, and then that's how you get, the nuclear bomb. That's how you get nuclear physics. Very significant development, obviously, that people like Heisenberg, Oppenheimer, Dirac, Plato, Richard Feynman to extent. All the big names in quantum physics of the 20th century played a big role, right? Once you get to the subatomic level, well, what actually is the subatomic level? What is the subatomic particle? In a sense, it can't even be described necessarily as a physical entity. And I'm going to read this quote here from Roger Penrose because I think he explains it very well. So he says, people often find it puzzling that something abstract, mathematical, really describes reality as we understand it. I mean, reality, you think of something like a chair or something made of solid stuff. And then you say, well, what's our best scientific understanding of what that is? Well, you say it's made of fibers and cells and so on. And these are made of molecules. And those molecules are made of atoms, which are made of nuclei and electrons going around. And then you say, well, what's a nucleus? And you say, well, it's protons and neutrons. And they're held together by things called gluons. And they're neutrons and protons and made of things called quarks and so on. And then you say, well, what is an electron or what's a quark? And at that stage, the best you can do is to describe some mathematical structure such that you say they're things that satisfy the Dirac equation or something like that, which you can't understand what that means without mathematics. I mean, the mathematical description of reality is where we're always led. End quote. So what he's saying here is why physicalism refutes itself is because even if you consider its presuppositions, and if you follow them through this chain of logical deduction, of reasoning, when you get to the bottom, you're seeing that what it actually appears to be physical reality is constituted more deeply by, mathematical equations in a sense. And that's also the bedrock of quantum field theory. When you study these things like gravity and entropy and electromagnetism and quantum fields, you're not really studying physical observables, if that makes sense. Things, it's not equivalent, for instance, to even to the structure of DNA or something like that, or to rocks, what geologists would study, or to animals or anything like that. And this can't even be studied under a microscope or as an observable. You're actually basically just devising these very advanced mathematical models and equations, but those aren't physical, right? Mathematics doesn't really have a physical existence. It has a conceptual existence in a sense, but not a physical one. And so, pretty much everyone accepts that. That's almost a unanimous position nowadays. So, and it's quite clear, obviously, right? It's just quite intuitive. And so that's where this gets really interesting. In a sense, we're coming full circle, and what we're doing, I think, with quantum mechanics, as we're going down to the subatomic level, is we're resurrecting the secret insights and discoveries of the past from long ago. We're talking classical era, ancient Greece, Platonism, and that notion too of circularity is something that's so important, because when you think about it, this gets very abstract, but the circle is a negation of linear time, because it asserts this interpenetrative nature, which the conception of time as space, as a spatial temporality, as defined by space, fundamentally excludes from within itself, in a sense, right? Because it can only because it conceives as time as physical, it assumes that it progresses in this linear fashion. But as John David brought up, we now know through findings like retrocausality that it's not the case. We know that events in the future can actually influence events in the past, and vice versa in a sense. That is actually affirming this circularity to time. And that's where you get into Jungian concepts, bro.
That can tie to like the interconnectedness, and like a theory of
that's where you get into fucking Jungian synchromysticism, the importance of the Ouroboros, right? The snake devouring its own tail. How it's a cultural universal to humanity. It's an archetype, right, bro? Think about it. When we started studying the structure of, I think there's a certain atom or certain chemical, something like that. The physical structure within physical reality of this one element, I think benzene or something like that, or named after that guy Benzene, is an Ouroboros circle. Bro, it's actually insane. There's some type of divine order that's happening here, and that negates that
exactly
that linear conception. Exactly. And think about it like this, and this gets very abstract, but what a field that's fundamentally related to physics, right? This gets very meta level. It's cosmology, which I'm very interested in, and people like Penrose and Sean Carroll dive into this sometimes, right? Well, there are obviously many cosmologists. I'm not just going to list off the cosmologists name by name, right? But cosmology is essentially, I think it's quite intuitive to anyone who's listening. They should be able to figure out what it is just by the name, but it's the study of the cosmos, right? Outer space, It would be closely related to things like astrophysics. And so there's this idea in modern cosmology, which is roughly referred to as the heat death of the universe. This idea that proceeding from this initial event, even though there's still a lot of speculation as to what the initial event is, I think that there are actually some problems with the Big Bang Theory. We could address that in a future podcast because I have some pretty crazy theories about that, about how I don't think it's correct. It leaves out very fundamental problems. But with that being said, proceeding from this initial event, what this model says, which is it's an accepted model in modern cosmology, is that the universe expands at a certain rate, that rate being the cosmological constant, which can actually be modeled mathematically, so it's a mathematical rate, a fixed rate, to the extent that it eventually collapses in on itself, and it actually implodes. And so what you get from there is the heat death of the universe. That's really how the universe ends. And how that manifests circularity is it returns the universe to the state of primordial chaos that actually preceded its existence. So the end reunites the universe with the beginning, in a sense. There's this cyclical nature of it. And think about it, how on the meta level circularity manifests here again, and that just brings us full circle back to the findings of the pre-Socratics, ancient Greece. Specifically, there was this thinker Empedocles, who was an ancient Greek cosmologist, who stated that he asserted what's called a cyclical cosmology. So he said the cosmos functions fundamentally on the basis of certain cycles that it proceeds through. And now think about what someone like Penrose asserts nowadays. He has this model called conformal cyclical cosmology. It's informed by his understanding of quantum mechanics. Do you see, are you understanding what I'm getting at here, John David? I know it's super abstract, but I think you could basically summarize it as there are these principles, these phenomena, these elements of reality that have this meta level existence. They seem to shape the universe, and they seem to indicate some type of divine or possibly transcendent order that negates this very hollow, shallow understanding that predominates today. That is basically leading us to the apocalypse, bro. It's fucking crazy,
dude. And Penrose has contributed some ideas to this.
Yeah,
or
cyclical, conformal cyclic cosmology, I think, is how he describes it. But that's what I was thinking of, and it's crazy that I thought of all of that just going off of describing mathematical Platonism. And obviously, then you contrast that with mathematical instrument nominalism, which just asserts that ultimately mathematics is just a social construct or a mental construct, and it's just something that humans devise to explain the natural world. It doesn't really have an objective or independent existence, etc., etc. So it's not too difficult to understand. Those are some elements that have to get that we have to address first. But I think I just tried my best to do so. Hopefully, I didn't ramble on for too much. But yeah, man, I just wanted to give you an opportunity to talk now because I've been talking for a while. What do you think about all these connections and everything? That's some crazy shit, bro. The DMT is
no, that was a lot.
Yeah, bro.
Let me think for a second, just to soak up all that and just decide what to add on to that.
Yeah, man. I know. I mean, do you think there's anything insightful in there at all? I know it's pretty crazy. Let me turn the lights on, man. But the third eye is being open right now, bro.
The DMT elves.
Might be.
The DMT machine elves.
Might be contacting the machine elves, bro.
All right, let me just think. I will say, you know what's interesting, Jordan?
Yeah, what's up, man?
It seems like we've been able to create intelligence by basically putting pieces of rock and metal together in a certain formation. I'm referring to artificial intelligence. It seems we've been able to make intelligence through putting metal together in a certain way. But there's definitely something more complex going on with consciousness. a lot of these physical collapse supporters, they think that consciousness and intelligence are connected. You actually got me thinking about this theory I heard one time called, I think, integrated information theory or something like that, where basically it implies that every single thing, even a carrot, has a level of consciousness or qualia, whatever you call it.
Yeah.
But the more information it has in it, like the more complexity or intelligence, the more technically conscious it is. Not everybody agrees with the theory, but that's out there. I don't think I agree with that. I don't know about that.
Wait, so you cut out for a second. Could you just repeat that last part? Something about the more X, the more Y.
The more complexity within the system, the more supposedly conscious it is.
Yeah,
and one of the reasons you could disagree with that is because we've basically made intelligence through putting rocks together, and it doesn't have a consciousness. So clearly, there's a lot of physical collapse people think that intelligence is a consciousness and things like that. But there's definitely there's a separation there. That's why I talk in the paper. Essentially, your consciousness, dude, it's like your soul. You know what I'm saying? It's like that. It's separate.
The hard problem of consciousness, because we touched on it earlier, obviously, but this is such a fundamental issue in the world today. I mean, this is one of the last frontiers of not just science, but of intellectual activity more broadly. To what is consciousness? Something that's so fundamental to our experience of the world. You could say it equals our experience in a sense, right? Because we can't have an experience of the world without consciousness. I mean, that follows almost logically, right? Science still can't provide an explanation for it. And so at least modern science, and so what the hard problem of consciousness is for the people listening, to give a brief rundown, is explaining how, in a sense, quantity translates to quality, or to quality, right? How these processes, the process of the physical world, right? So things like, the spin of particles and vectors and all of this give way to and translate to, taste, smell, feelings, emotions, all of these aspects of consciousness and aspects of a conscious experience. Because, for instance, it doesn't necessarily follow from these mechanistic processes of the natural world that any given sensation should be felt over another sensation, right? The feelings of for instance, a certain taste, right, and the pleasure that aligns with that taste, don't necessarily have to follow from the mechanistic processes that would be involved in the acquisition of, for instance, the food that you would assume is giving you that taste. It could.
I see. Yeah, getting at that, but that definitely gets a lot more philosophical and deep.
Yeah, it could theoretically have a different taste. So it's explaining qualia. That's a fundamental aspect of
being experiencing
a hard problem of consciousness. And I think, as I said, physical. It definitely shows the limits of physicalism, man. Same thing with quantum mechanics. That's how it's all interrelated, because it's obvious that consciousness transcends the physical. And that's where it gets crazy, because that requires complete reevaluation of the consensus understanding of reality, dude. That's why it's so significant. But anyways, so what I wanted to say here, though, is I think we've been going for how long? Maybe an hour and a half? How long would you say, guys? Because
I think it's been like an hour.
An hour, yeah. Because the thing is, I really have to wrap up the podcast, which is something that I have to attend to right now.
We have been going on for exactly an hour and 25 minutes.
Okay, hour and 25 minutes is good enough for this podcast. I do have to wrap it up here, but what I'll say is...
It isn't good enough for the podcast?
No, it is. No, I said it is.
Okay.
Yeah. I said it's more than good for an episode. That's
wow, I love how much I contributed to this one,
Yeah, don't worry, man. But what I'll say is part 2 is definitely gonna happen. We need a part 2 for this. I mean, there's so much that we haven't. But beyond that, Scorpion Movement is the greatest podcast. We are taking over. This is revolutionary, groundbreaking content. You're not going to get this anywhere else. And with that, I'm going to give it to you, John David. Do you have any concluding remarks for this base podcast? We contacted the machine elves, bro.
I will say This is
Go ahead, bro.
there could be a deep sea creature that can only taste and smell.
Dude, there can be a
So
very large deep sea creature that can only taste and smell. That is only limited to those two senses. And if you venture far down beyond into the Pacific Ocean, it might smell you. And then it might want to put its big tongue around you and roll you up. So be careful when you're swimming out there, guys. Sharks are not the only thing to worry about. They're our friends.
You, you,
The blahages in the sea are our
yeah,
friends. They're very
you might,
trustworthy.
might
I think we
also,
should worry about the Cthulhus and
yeah,
the other
this was my
Lovecraftian
favorite part of
creatures.
the whole podcast.
no, you might also
Lovecraftian
encounter,
creatures
Highlight right
lurking
here. This
below
is
the
the
no,
seas.
highlight.
no, you might also encounter the Nazi aliens who live in Hollow Earth, in Agartha, in those underground,
Gartha.
yeah, in the underground tunnels.
And
And they're
remember,
actually,
kids, no matter how much you might like H.P. Lovecraft, don't
yeah,
name your cats the way he did.
yeah, and they're actually going through the tunnels in Antarctica that Klaus Schwab's trying to hide from us.
Exactly.
Yeah,
Do you guys know that Antarctica was actually once the habitable Hyperborean Argarthian
yeah,
plain, and
it
that
was.
they buried it in ice to cover up all its secrets?
Yeah, with the Aryan
Oh,
giants.
I thought it connected to Atlantis through the snow
It
tunnels
does
Can
of
we
actually.
please
Agartha.
do a Hyperborea podcast?
Yeah. Okay, bro. We've got to wrap this one up though, because now we're just
Okay.
riffing. Yeah, but it was a great podcast. Yeah, we're gonna have a
I
schizo
had fun
podcast.
listening.
Yeah, we're gonna have a schizo podcast about Hollow Earth and Antarctica next, so that's gonna be fun.
Bro, we need to
Flatter
do a
podcast
podcast
with
with like
Zerka,
a
please.
liberal.
Wait, Jacob, are you still recording or not?
Yes, of course. Okay, I'll
Okay,
finish it
yeah,
up.
but that's
Thank
it.
you guys for
Yeah,
watching.
great podcast. Yeah, thank you.